everyone. We are now ready to take our convolution structure into the Vivado development environment for deployment onto our FPGA. But before we do that, this video is all about opening our project and simulating our design. So, now that you have Vivado open, let's begin by creating a new project. You can save your project in the same directory as your HDL files, or create a new folder if you prefer. When prompted, choose RTL project and click Next. Then add your HDL files. The folder containing them should be where you saved your Simulink HDL output. Since this is a relatively small design, setup is pretty quick. So select all of these files and choose your target language. It can be either VHDL or Verilog, depending on which language you generated. Leave all other settings as default and then click Next. We won't be using a constraints file for this simulation, so you can skip that step by clicking Next again. So we're going to choose our FPGA evaluation board. Since I'm targeting my evaluation board today, I'll select board and choose the Z board. Once that's selected, click Finish. Once your project opens, take a look at the file structure. You'll see that the top level file has a small pyramid icon. This indicates the entry point of your design. Click this caret next to it to reveal all your file dependencies. Everything generated from your Simulink model will be listed here. Before simulation, it's important to understand what signals your design is using. Let's double click this top level module. You'll see standard input ports like clock enable, reset, and your output signals. To simulate properly, we must initialize these input signals. So we start by setting clock and clock enable to 0. This ensures a clean start. We could set reset to 1, then your entire system will start in an initialized state. You do this with a colon and equal sign with the initialized value in single quotes beside each of these input signals, like I'm doing here. On the pane over here, we want to click Run Simulation. Now let's start by giving our input signals stimulus. Now right-click on the clock signal and choose Force Clock. Choose Binary. For leading edge, we will place a 1. Trailing edge is a 0. And we will keep this period. This clock will drive the entire simulation. Now we configure the reset behavior. Right-click the reset signal, choose Force Constant, select Binary, and set it to 0 after 500 nanoseconds. This gives the system enough time to initialize before processing begins. Now we're going to repeat the same steps for clock enable as we did for reset, but this time we set it to start immediately with no delay, just like I'm doing here. We want data to start flowing as soon as the reset is released. We're now ready to simulate. Set the simulation time here to around 3 microseconds, which is sufficient for this small design. And now we press this arrow key with the M, and we run our simulation. Now, we're mainly interested in the output signal Y. So right-click this signal in the simulation waveform window and choose Change Radix to Sign Decimal. This will display the output values in a more readable decimal format. Now you'll see the correct expected output data flowing, 1 sample per clock cycle, just as expected from our Simulink model. This confirms that our HDL design behaves correctly in simulation, a critical step before loading it onto real hardware. In the next video, we'll move forward with synthesis and implementation on the FPGA. Please click subscribe, like, and leave a comment. Thanks for being a part of this DSP